Welcome back, everyone, to the deep dive. Today we're going to really get into the nuts and bolts of something that's like absolutely crucial to how our digital world works. I mean, we're talking response time testing for APIs. It's kind of like those connections you don't see, but they're like humming away behind the scenes whenever you use an app or browse a website.
Absolutely. You hit the nail on the head. Like at its core, we're talking about how quickly one part of a system, any system really, answers another one's call. And specifically, when we zero in on APIs, it all boils down to how long that API takes to do its job and send back that info. A lot of times it comes all neatly packaged up as JSON. Think of it like we're actually timing the server's reaction to every single request.
Okay, so let's unpack this a bit. Say you're shopping online, right? And you see a product image that catches your eye. You want to see more details, so you click on it. Chances are that click triggers an API request. Where exactly are we starting and stopping the clock to measure the response time for that whole interaction?
Well, the clock starts ticking the very instant your device, your phone or computer, sends out that request. And it doesn't stop until the application signals it's got the full response back and has all those juicy product details ready to show you.
Okay, I'm with you. Now, all the material you sent me, it really digs deep into understanding and improving how well our systems actually perform. So what we're aiming for in this deep dive is to pull out those key insights, like how do we measure response time? And maybe even more importantly, why does speed matter so much in this whole context?
You got it. And the first thing all these sources highlight is the general method we use to even get these measurements. It all revolves around using special testing tools. And these tools essentially mark the beginning and the end of a specific business process. They kind of put a fence around it, so to speak.
So what kind of process are we talking about? Could you give me a real world example?
Sure, think about when you log into your online account, or all the steps someone goes through to buy something online. A testing tool would place markers, a start and an end marker, around all those API calls and interactions that happen during that whole process.
So we're not just timing one single API call, it's the whole shebang.
Exactly. But here's where things get kind of interesting. If you took that same API call and measured it using two different testing tools, you might get slightly different numbers.
Wait, really? I mean, a millisecond should be a millisecond, right? So what's causing the discrepancy?
Yeah, it's easy to assume they'd all be the same, but our sources point to a few reasons why those numbers might not match up perfectly. First off, each tool could have its own little quirks, like its own unique way of calculating all those performance metrics it's collecting.
Got it. So different ways of crunching the data could lead to variations in the final numbers. What else could be throwing things off?
Oh, there are a few other things. So, like the way these tools simulate lots of users hitting the system at the same time is what we call load, and how they capture the speed of all those interactions. Those methods can vary a little between tools. And on top of that, some tools might record extra diagnostic info while they're pretending to be all those users.
Right, like keeping track of what's going on behind the scenes.
Yeah, exactly. But all that extra recording can sometimes add a little bit of overhead that messes with the timing. Plus, just the fact that the testing tool itself has to process all that data to generate those fancy performance reports that takes up resources and can tack on a tiny bit of extra time. And lastly, just the way the testing tools are designed, their architecture might have some little differences that affect those measurements.
So it sounds like while the basic idea of measuring time is the same, those little details about how each tool operates under the hood can make the readings a bit different. It's definitely something to keep in mind when we're looking at those test results. Now, shifting gears a bit, what are we actually measuring here? What are some of the key response time metrics?
Okay, so there's this thing called average response time, right? That's a big one. It's pretty straightforward. It's basically the average time it takes for every single request in a test. You just add them all up and divide by the total number of requests. Simple. But here's the catch, that average isn't just about the API calls themselves.
That's not.
Nope. It also includes the time it takes to download everything else that goes along with a web page or an app, like the basic HTML structure of the page, the styles from CSS, all the images you see, even those bits of JavaScript code that make things interactive.
So if there's a huge image on a web page that takes forever to load, that's going to drag down the average response time for everything else on that page, even if the API calls themselves are super speedy.
Exactly. That's a great way to put it. Our source really stresses that those slower components can really distort the big picture, the overall average. It could mask the fact that individual API calls might be causing bottlenecks behind the scenes.
So the average gives us a decent overview, but what about when things go wrong? Do we have a metric for that?
Yeah, so while the average gives you that general picture, this thing called peak response time is really important for spotting those trouble areas, those hiccups in your system. It helps you zero in on those specific requests that aren't being handled efficiently.
Okay, I'm following you. Can you give me an example of what we might find with peak response time?
Sure, our source uses this example of a database query that's not optimized. Imagine your API needs to grab a bunch of data from a database. Now, if that query, the request, is written in a way that takes a long time to run, or if the database itself is overloaded and struggling to keep up, that single slow database interaction can really spike the peak response time.
Ah, so even if the rest of the process is running smoothly, that one slow database query could throw things off for that specific user.
Exactly. It can make things feel really slow for them. And then there's the error rate, right, that ties into all of this.
Right, the error rate, how does that fit in with response times?
Well, the error rate is basically the percentage of requests that didn't go through, that failed for some reason.
Hmm.
That includes those HTTP error messages, like when you see that 404 page not found thing, or when a request takes so long that it just gives up and times out.
Okay, so it's basically the number of failed attempts out of all the attempts made. A high error rate definitely sounds like a red flag.
It is. And it can often be a sign that there are underlying performance problems that are also causing those slow response times. For example, if your server is totally overloaded, it might start dropping requests altogether, leading to both slow response times and a high error rate. It just can't keep up.
So a sudden jump in error rates could be a sign of a bigger problem.
Yeah, like something is really impacting the API's ability to even function, not just making it respond slowly. Now, your sources dive into some really important response time values and why they matter so much for how users actually experience your application. And the first one they highlight is zero point 0.1 seconds. That sounds crazy fast, right?
It does, like blink and you miss it fast. But the source makes this really interesting point. If your system can respond within that super fast 0.1 second window, users don't even register it as a delay. They just perceive it as instantaneous. There's no interruption, no break in their flow.
It's that smooth, seamless feeling that makes using an app or website so enjoyable.
Hmm.
But then what happens when it takes a bit longer? Our source says the 1.0 second mark is where things start to change.
Right. The source points to that 1 second mark as kind of like the edge of what's acceptable. Users might sense a little pause, a tiny bit of lag, but it's not necessarily enough to make them frustrated or disengage. But here's the thing, as soon as you go beyond that 1 second mark, their experience starts to go downhill.
Yeah, that 1 second threshold is a real tipping point for how users perceive things. If you cross it, you risk losing their attention. They might get impatient. And then there's the 10-second mark, which feels like an eternity when you're online.
Absolutely. An eternity. Our source says 10 seconds is the absolute maximum, the point where the response time is just unacceptable for almost any interactive application. But you know what's even crazier? In today's world, a lot of users will actually abandon a website or an app after just 6 seconds of waiting.
It's wild, right? Patience online is in short supply these days. So just to summarize those key values for you, the general rule is to shoot for that near instant zero point 0.1 to 1 second window. That's what delivers the best performance and keeps users happy.
And it's not just about keeping users happy. Our source talks about how slow response times can actually cost businesses money.
Right. Slower response times can lead to lower user satisfaction, which can translate to real costs for a business. Like they might get more customer support calls, negative reviews, and even lose customers altogether.
Yeah.
But on the flip side, faster, more responsive systems generally lead to more loyal customers and potentially lower operating costs.
Makes sense. All right, so we've covered what response time is, how we measure it, and why it's so important to hit those speed targets. Now let's get into the tools that allow us to actually do the testing. What can you tell me about JMeter?
Well, JMeter is like a rock star in the open source world. It's specifically designed for load testing. Now, it's primarily known for evaluating how websites perform, but as your source correctly points out, it can also be used for API testing within a DevOps environment. That's where developers and operations folks work closely together to release software faster and more efficiently.
So it's pretty versatile. What are some of the other advantages of using JMeter?
Well, for one, it's incredibly flexible. You can use it to run load and performance tests on all sorts of server types, not just those that handle web traffic. Interestingly enough, it stores all its test plans in XML format, which makes it easy to share and edit those plans if you need to. Plus, JMeter is great for both automated testing, where those tests are run automatically as you're developing software, and functional testing, which is all about making sure that the API behaves exactly the way it's supposed to.
Got it. So it sounds like it's a pretty powerful option, especially considering it's free to use. Now, the other tool your sources mention is LoadRunner. I've definitely heard that name thrown around before.
Oh yeah, LoadRunner is another big player in the testing world. It's developed by Micro Focus, and it's often seen as a good alternative to JMeter. One of its biggest strengths is its user-friendly interface for monitoring and analyzing all the test results. It's really visually oriented with lots of colorful charts and graphs.
Oh, that's helpful, especially when you're dealing with mountains of performance data.
Absolutely. Those visuals can make a huge difference when you're trying to make sense of it all. But there's more to LoadRunner than just pretty graphs. It's also designed to support continuous testing, which is really important these days because software updates and changes happen all the time. It's known for performing well in large enterprise environments and can handle testing APIs that use different communication methods. We call those multi-protocol scripts. And lastly, it plays nicely with a lot of other developer tools that teams commonly use.
Okay, so JMeter is the open source workhorse, and LoadRunner is the commercially supported option with a more visual approach. They both seem to have their strengths.
Yeah, you hit the nail on the head. It really depends on what you need and what kind of environment you're working in. They're both great tools for different reasons.
All right, let's wrap up this deep dive by going over those key takeaways just to make sure everything really sinks in.
Sounds good. So we started with the idea of response time. It's simply how long it takes for a system to react to a request. And when we're talking about APIs, we're specifically interested in the time it takes for the API to do its thing and send back that data.
And to measure all of that, we look at things like the average response time that gives us a general idea of performance and peak response time, which can help us identify potential bottlenecks and issues.
Right. And we also can't forget about the error rate. That tells us how many of those requests failed. And remember, those three key response time thresholds, zero point 0.1 seconds for that instant feeling, 1 second for that just noticeable delay, and 10 seconds, which is basically the point of no return.
Right, the absolute maximum. And lastly, we talked about those two popular testing tools, JMeter and LoadRunner.
Yeah, solid tools for the job. Understanding these concepts and the tools available is really crucial if we want to build efficient and user-friendly systems.
Well, this has been a super informative look at response time testing. Now, before we go, a little something for you, our listener, to ponder. Think about those response time thresholds we discussed, from that super fast zero point 0.1 seconds to that dreaded 10-second mark. What are some unexpected bottlenecks that might be hiding in the systems you use every day? Whether it's at work or in your personal life, are there any slowdowns lurking that you haven't really thought about before?
It's definitely worth thinking about. Until our next deep dive, keep an eye on those response times.